Assalamualaikum. I wish to our lecturer. I, Ismail bin Hussein, and group members will explain about the refrigerator. Basically, for heat pumps, air conditioner, and refrigerator utilize heat transfer from cold to hot. They are heat engine, can backwards. We say backward rather than reverse because except for cannot engines, all heat engines, so do they can be run backwards, cannot truly be reversed. So we start with compressor. Compressor generate heat and start pump the gas. Pressurize the system it to move the refrigerant around the system. The gas going come on out through this discharge line. The line is superheat vapor. After that, the gas is go through the condenser. When in condenser, the gas has high temperature and high pressure. At this point, first is this is gas. After that, at this point, condenser start cool that vapor in refrigerant, and then the gas starts saturation, which is gas change to liquid. After that, the liquid go to the liquid line. Liquid line is subcool liquid with full column of liquid. In the process, we are in saturation. After that, the liquid get into the metering device. Metering device is to regulate the flow from the system, condenser system, and the evaporator system. The difference between condenser system and evaporator system is condenser has high pressure and high temperature. Different with evaporator. Evaporator have low pressure and low temperature. After that, the liquid going to flash line, and then get into the evaporator. In this point, here there is 75% of liquid and 25% of gas or vapor. As we can see here, there are a lot of liquid here that we have to boil off that liquid. The evaporator, so the evaporator job is to absorb heat. Here point having a residential setup, a blower fan pushing air across the evaporator. After absorb the heat, liquid slowly change to the gas with low pressure and low temperature and become the cool gas.
Assalamualaikum. My name is Muhammad Adam Barik bin Yusuf Paliza. I'm going to present about thermodynamic theory of a refrigeration system. As we see here, this is the usual refrigerator in common household, which have cold region and hot region. Okay. Introduction of refrigeration. A type of heat engine in the work is done on a refrigerant, usually R32 gas, in order to collect energy from a cold region, which is QL here, cold reservoir, and channel it to higher temperature region, QH, usually which is the hot reservoir. It uses a refrigerant usually R32 gas, which is better to the environment as a working substance in refrigeration system by lowering and raising the pressure in the system. By manipulating the pressure in the system, we can get two state of matters, which is gas. If we lower the pressure, and when the pressure is high, we get liquid form. From the first law of thermodynamics, the core reservoir, or in this case refrigerator, in the top side of the freezer, further cools down, and the surrounding kitchen or atmosphere we get hotter. In this formula, uh, the lower heat added with work done into the system, we get a higher heat. Okay. Next, we get to efficiency of refrigerator. Efficiency or coefficient of performance (COP) and or better known as beta is the benefit of a cost ratio. The greater the COP or beta, the better the condition of the refrigerator. As we see here, lower heat over work done. A typical refrigerator has a CP around 5 to 6. Usually, a refrigerator or any typical engineering system have a efficiency lower than the ideal system. The heat is taken from cold object to hot object by doing external work. Without the external work, heat cannot flow from the cold object origin to hot object origin. Okay. A refrigerator has a COP of 5, which is good in a certain way. How much work must be supplied to the refrigerator in order to remove 250 joule of the heat from the exterior? Okay. As we know from this formula, we can get work done by 250 divided by 5, or the COP value, and we get 50 joules. From the example, the system require the system required 50 joules to get rid of 250 joules of heat. If the COP is higher or lower, the work given also be different in quality. Thank you.
Assalamualaikum. My name is Muhammad Hanan Razi bin Azman with matrix number of B0N1910031. Now we'll be presenting about the advantages of the system in the refrigerator. The first advantage of the refrigerator system is that it can preserve food. By using the refrigerant system such as refrigerator, food processing can be carried out in the optimal hygiene condition because it keeps the cooling chain inside the refrigerator as it preserves food from bacteria activities because the bacteria can be performed actively in the low temperature condition. The second advantage of the refrigerator system is that it can also be used as a transportation purpose. For instance, when a company is shortage of product and that product also is hard to maintain its condition such as ice or something alike, a refrigerator is handy as a transporter device to carry the product until it reaches the destination. This is an example of a refrigerator attached on a vehicle. The next advantage of the refrigerator is it consumes much less energy than we expected because of its compact size. As for a refrigerator that we usually use at home, it uses much less energy because of its compact size, but still it can put many products in it at once. especially the product of the refrigerator that have 4 or 5 star energy consumption, that it will really help save the energy from loss. This is an example of the energy consumption star that we usually see at the refrigerator. Other than that, because of its compact size, it uses much less space occupancy that we need to put it at home. This is an example of size that we usually see when we put at home. The next one is the maintenance cost. The maintenance cost is low too because there is no complicated part in the refrigerator to be maintained. Last but not least, the refrigerant air is easily available, also inexpensive. What the most important thing is that it is safe because the refrigerant air is a non-flammable stuff and non-toxic refrigerant. Plus, there is no danger to any kind of leakage will be occur. That's all from me. Thank you very much.
Hi, my name is Muhammad Ozi, B08191016 We continue about disadvantage about the system. System disadvantage. Disadvantage of the system is first, freezing of the moisture in air used in the system. Secondly, refrigerating effect per kilo of air. Lastly, the work input is sometimes more expensive. First, freezing of the moisture in the air used in the system. This is particularly for open system. A deposit of snow is liable to choke up the valve and duct carrying air. Moisture contained in the air is a big problem, as moisture condense and even freeze, choking the valve and creating problem for the running of this air system. We can see example as the picture at right side us. Next, refrigerating effect per kilo of air. Refrigerating effect per kilo of air is comparatively small, or to produce the required refrigerating effect mass of air required is large. As shown like the graph at the left side, the volume of air dealt by compressor and expander is very large, so the machine is heavy and bulky. Lastly, the work input is sometimes more expensive. It's most expensive than simply burning fuel, especially if the work is done by electrical energy required by the second law of the thermodynamic state, that the entropy of any isolated system always increases. The power required to get unit of refrigeration is comparatively large and hence the performance is very poor. It is observed that approximately 4 kilowatt are required to produce 1 ton of refrigeration. For vapor compression refrigeration system, power required is approximately 1 kilowatt only for every ton of refrigeration capacity. Therefore, the air refrigeration system is to be used when other system cannot be used. So, conclusion of the system. As conclusion, heat pump and refrigerator utilize heat transfer from cool to hot. They are heat engine run backwards. Heat transfer occurs from cool reservoir and into a hot one. The required work input is also converted to heat transfer. Thus, the heat transfer to the hot reservoir, the mission of refrigerator is for heat transfer to occur from a cool environment, such as keeping food at lower temperature than the environment. Lastly, a heat pump also can be used both to heat and cool a space. That's all from us for this presentation and assignment. Thank you for watching.